Hello everyone, today I'm going to show you how to set up LSP mode on Windows for C and C++. LSP mode basically gives you almost the full IDE experience in Emacs. You can compare it to Visual Studio Code, for example. LSP mode gives you features like code highlighting, syntax checking, code completion, jump to definition, find usages, and so on. LSP is short for Language Server Protocol, and the LSP mode in Emacs is basically a front end for the back end, and the back end is just a language server that runs as a separate process, and you need a separate language server for every language. So for example, if you want to use Python, you need a dedicated Python language server. If you're using C and C++, you need a dedicated C++ language server. And in our example, we'll take a look at Clangd, which is going to be our language server for this video. So let's first take a quick look what we actually need in order to run LSP mode properly. So we're going to need flycheck, which is going to do our syntax checking for us. We're going to need company mode and LSP mode. We get all three of these from list packages inside of Emacs. I'm not going to show you how to set up flycheck and company mode, since I've already covered this in another video. But we're going to take a really close look at how to set up LSP mode properly. And we're going to use a language server, which is going to be Clangd in our case. And we're going to create a compile-commands.json file. And the compile-commands.json file is basically the file that Clangd, our language server, is going to use to find variables, find function definitions, and so on. So you can't run the language server without having a compile-commands.json file in your project. In our example, we're going to use CMake in combination with the build tool Ninja. There are also other options. For example, there's a Visual Studio plugin that you can use. You can use CompileDB, which is in Python, if I'm correct. On Linux or on Unix systems, you can just use CMake in a standalone version without Ninja. And you can also, for example, if you're using classical makefiles in Linux, you can use Bear, which is a build-ear. So yeah, let's get right into it. So let's take a look at the packages. We're going to hit Alt-X or Meta-X and enter the list packages. So the first thing we need is flycheck. Give me a second. There we go. I have, of course, already installed flycheck. Flycheck basically does syntax checking for you and works in combination with LSP mode. Flycheck needs a compiler. As I said before, I'm not going to show the complete setup. You can look that up in a different video. I'm using GCC or G++ compiler for flycheck, which is from the min.gw installation. The other package that we're going to need is company mode, or company. Company basically is complete any, and it does not require any additional setup. And the last thing that we need is LSP mode. You can just search for it in the Melpa packages, and then you can install it from in here. So after you have installed LSP mode, we have to add 2 lines to your .emacs file. You can find your .emacs file under users, your username, appdata, roaming.emacs. There we go. And we have to add these 2 lines. The first one, require LSP mode, basically activates the package, and the second one adds a hook. So whenever we open a file that is a programming language file, like for example a .c file, a .cpp file, LSP mode is going to try and start the language server. So after we have restarted Emacs, our changes in the .emacs file should be active and LSP mode would try and start a language server. But we don't have a language server yet. So let's take a look at getting a language server and setting it up in Emacs. As I've mentioned before, we are going to use Clangd as our language server. In order to get Clangd, we're going to take a quick look at Firefox. I'm on the Emacs-lsp github.io lsp-mode page, just the lsp-mode page on GitHub. And at the top we have languages, so we can follow this link, which gives us a list of languages to choose from. One of them is our Clangd server, which we're going to use, and via this link we go to the Clangd page, which is clangd.llvm.org, and by going to getting started we get the download page. As you can see, there are several options, several OSs. We are looking at Windows, and you basically have two options here. You can get the complete LLVM installer from a package manager, which is via this link. And here we can get precompiled or pre-built binaries, which is down here. Or if we go back, we can get standalone.zip releases, and this is this link, which gives us this little page where we can go and download the Clangd Windows 10.0.0.zip. And we're going to download it now and have a look. So after the download and installation is complete, we are going to have to find the Clangd executable, because we have to tell Emacs where to look for the executable in order to start it via the LSP mode. So I'm just going to show you the path really quick in my example. Let's take a look at the command shell. I have installed the Clangd server in the dev, and there is the LLVM folder. So let's take a quick look into it. As you can see, there is a binary folder, so let's go in there, and in the binary folder we should have an executable. There it is, that is called Clangd, and this path is the path we're going to have to input into Emacs in the settings and tell it where exactly it can find the executable that it has to start when we are opening a C or CPP file, for example. So now that we have the package, LSP mode, we have the package company, we have flight check, and we have downloaded the language server, we can do the last setup that we have to do in Emacs, which is basically tell Emacs where our language executable server is. So we open up Emacs and we hit meta-x, and as you probably know, you can basically change any settings of any package by inputting meta-x customize group, and we look for LSP mode, as you can see, so completion. We hit enter and we get all of those nice little settings that we can have. For example, I don't know, LSP, disable clients, update hook, clean after change, and so on. But what we're looking for is our Clangd settings, and those are at the bottom. Here we go. Here are all our language servers, and we are looking for LSP Clangd. Here we are. So we enter it, press it. I have already set it up, which is the path that I just showed you, and then we can apply and save, and Clangd is pretty much set up now. So let's take a quick look. Let's open a file. So do I have a file? Test.c. So now I have told Emacs I want to open this file, test.c, and the LSP server or Clangd server has noticed that it's not part of any project. So as I told you before, we need a compile commands JSON file, and there's no compile commands JSON file in this folder. So it gives me a variety of options. Do I want to import the project root? Do I want to select the root directory? And what I'm going to opt for is do nothing and ask again when I'm opening another file, another C file or another CPP file. And as you can see, now we have the file open, and LSP gives us a notification that test.c is not in a project or it is blacklisted. So basically LSP mode and the Clangd server is not active right now. That means that we now have to create a compilecommands.json file. And as I have mentioned at the beginning of the video, we are going to create our compilecommands.json file with CMake and with Ninja. So first you have to get CMake. CMake is pretty well known. You probably know more about CMake than I do. You can get it from cmake.org, and up here there is a download, and we can scroll down a bit and there's a Windows x64 installer and an x64 zip, and you can choose whatever you like and download CMake. So that's pretty straightforward. One thing to note is you have to make sure that CMake is part of your system environment variable of your, so there's a path system environment variable, and the folder cmake/bin should be part of the system environment variable, because otherwise you will not be able to use the CMake command in your shell, and that's what we're going to use later on to create the compilecommands.json file. So after you have successfully added your cmake/bin to your system environment variable, or to your path system environment variable, you should be able to do this in your command shell. So you should be able to enter CMake version, and if everything went right, you're going to show your CMake version, and now you know that you have set up CMake properly. Now that we have set up CMake, we have set up LSP mode and the packages in Emacs, we just need to get our build tool, and we're going to visit the Ninja build homepage. It's ninjabuild.org, and as you can see, Ninja is just a small build system. We're going to use CMake to generate a Ninja file, and we're going to use Ninja to create our compilecommands.json file. And you can download Ninja down here and just press download the Ninja binary, and let's take a look. So after downloading the Ninja binary, I'm going to show you what it should look like on your end. I'm again in my dev folder. I have downloaded it to this folder, the Ninja-win. So let's cd right into it. And as you can see, there's just one executable, nothing else. And that's all we need. The next step that you also have to do is you have to add the Ninja-win folder, or whatever it's called on your end, to your path system environment variable the same way you did with CMake. And now, after you've done this, we have all the tools that we need to create a compilecommands.json file and start using LSP mode. So now we can start and create a compilecommands.json file for our project. The command prompt that I'm using is the developer command prompt that comes with a Visual Studio. I'm just going to assume that you have Visual Studio installed on your machine, since we're going to need the CL compiler, the command line compiler from Visual Studio. You have to make sure that you're launching your command prompt in administrator mode, and I'm just going to show you real quick what I'm going to do. So this is my command prompt. I'm just on my C, first we have to go to the Visual Studio and run vc vars bat.all. Just going to show you in a second. Here we go. In Microsoft Visual Studio, your Visual Studio number, community, VC, auxiliary, build, we have the VC varsall bat. And this is going to set up CL for this command line. So we go, and we're going to set it up for x86, which is 32-bit. And there we go. Now CL is set up properly, and we can enter CL, and as you can see we get Microsoft, some German, and yeah, CL is set up now. So now we can move our CD into the project that we're looking at. I have prepared a little, that's wrong. I have prepared a little something. It's nothing special, it's just a C file and a header file. And in order to use CMake, you probably know that better than I do, since at work we are using classical make files, we're not using CMake actually. You have to create a CMake list.txt, and we can take a quick look into this file. My CMake list.txt file looks like this. It's just a project name, just a random name. It's the source files, our C file and our header file. And now the important part: in order to create a compile commands JSON file, we have to set this variable. It's set CMake export compile commands on. And then we just add executable, we have our executable name and our source files. And without this line, we're not going to create a compile commands.json file. So let's switch to our command prompt again. We are in the same folder that our CMake list.txt file is in. As you can see, there's our C file, our header file, and as I said before, our CMake list.txt file. So now we can run CMake by entering CMake, and we have to give it the CMake list.txt file. But if we would run it this way, CMake would by default, if you have installed Visual Studio, would create a solution and project file for Visual Studio. But if you're using, or if you're creating a solution and project file for Visual Studio, the CMake export compile commands does not work. So we're not going to create a compile commands.json file, and that's what we're actually trying to do. So what we can do is we can enter -g, which is for generator, and we can give Ninja as the generator. And we have set up Ninja before. We have added the path environment variable, so our command prompt is going to find our Ninja executable. And by using Ninja, or Ninja is actually capable of creating a compile commands.json file when the export or CMake export compile commands variable is set to on. So let's hit enter. As you can see, we have configuring done, generating done, build files have been written. So let's take a quick look into our folder. As you can see, there is a build Ninja file, so we can actually create an executable by just entering Ninja. We have a cache file, we have some CMake files, we have some more CMake files, and there it is, it's our compile commands.json file. And we can also take a quick look into it. Let's switch to our Emacs. Now we're in Emacs, and we can open the compile commands.json file. It's just nothing special, it's just a list of directory commands, which compiler we're using actually, our C files and object files. It's Nothing special, but our LSP or our language server will be able to read the file and infer from it where all the variables are and so on. So now that all the setups are done, we can finally take a look at our C file and let's see what lsp-mode can do for us, or what has changed from before. So first thing to notice that's really important, down here we get the confirmation LSP connected to Clangd and the process ID, and down here in the minor mode we also see LSP Clangd is active. So this is confirmation that everything is working as intended. And the first thing to note is our header files or includes are underlined, and you can jump to the header file as you might be used to from Visual Studio, for example, by holding Control and pressing the left click or the left mouse button by left clicking. And as you can see, we jump immediately to our stdio.header file, and as you can see, stdio is not in the project, so we don't have the compile commands file, of course. We can jump back by hitting Alt and comma. Let's see, let's jump to our main function. Let's take a look at some code completion. We have the local double multiple and the function multiply. We get this list. Something to note is that the code completion is actually different from other editors. So if I were to hit enter, if I were to hit tab right now, it would not complete the whole word. It would only complete up until the point that the two options differ. So I hit tab, and it will only go towards multiple without the E or the Y. And if I want to complete to a specific selected member of the list, I have to hit enter. What else can we do? We can, for example, call the function multiply, and what we get is we get a little window down here which will show us what the function arguments are. If we have set up flight check correctly, it will tell us that we have too few arguments at the moment. It's expected 2 and we have 0. Another nice feature is jumping to variable or function definitions. We can do this by hitting Alt dot. There we go. We jump to the header file. As you can see, LSP is still connected to our process. Clangd is still active. We can jump back by pressing Alt and comma. There we go. Now we're back. Another cool feature that's very useful is if we want to find all the usages of a certain struct variable, for example, which can be very helpful, is we can enter Alt X, meta X, and then we enter lsp -find -references. And if we hit enter, we get a nice little window at the start, and as you can see, we have all the instances that height is used, and we can jump to it by either pressing with a left click, or we can just move with the cursor and press enter, and we are at the correct line. Another useful feature is that we can jump up and down. If we have some suggestions, if we have a list, we can hit Alt and N and we jump down, or Alt P and jump up in the list. And yeah, that's basically all I want to show you. We have set up LSP mode. It's been working fine, and I hope this video helps you setting up LSP mode for you, and have fun with it.